All right, welcome back everyone. This is part 4 of my Utility AI and Unity tutorial series. In the previous part, we spent time going over coding out the logic for scoring actions and how to pick out the best actions from a list of available actions. So in this part, we will be actually coding out real actions that the NPCs can do. Specifically, 3 very simple actions: eating, sleeping, and working. Okay, we'll be laying the grounds for those actions, and then fleshing them out as the series continues. Okay, so let's go ahead and first start making some new folders and clean up things here. Let's put all our core scripts together into their own separate folders, and then we'll make a folder specifically for our utility AI scripts. Okay, and as we said before, the core scripts we have are things like the move controller, the NPC controllers. Oh, let me close that up, and then actions, brain, consideration, AI brain, and consideration. Those are all utility AI scripts. Okay, and then in our utility AI scripts, we're going to go ahead and create 2 new folders. We're going to call them our actions folder. So this will be the folder that holds the scripts for all the real actions that we'll be performing, and the considerations folder that will hold all our scripts for our actual concrete considerations. Okay, so as I said, the concrete actions that we will be giving our NPCs, 3 of them, the most important ones, are going to be eat, sleep, and work. So let's go ahead and create those scripts. Okay, so let's go ahead and start with work, since it's the first one that popped up. Okay, so work is an action that this NPC can do, and it should inherit directly from our abstract action class that we scripted out here in the previous episodes. So let's go ahead and implement or inherit from action. Okay, and then let's do some housekeeping here. Let's put them in their own namespace. And then make sure that we are using the right namespace here also. Okay. Now let's check it. Yep. Okay. No. So this is from utility AI, and the red squiggly line because we are not implementing everything that is required of the action parent class. Let's go ahead and implement it. And so you see, because work inherits from action, the only thing that actually has to appear in the work class is just the execute method. And as we discussed before, this execute method contains the logic that actually makes the NPC do whatever it needs to do to perform the work action. So such as playing animations, updating any stats like money that it has or items in its inventory and all that. Okay, so we could do one of 2 things. We could actually write a lot of messy code here to actually do all the stuff that goes into making the NPC work, or we can just call in an external method from somewhere that does all that logic. And from my own experience of going through this over and over again, what I found that works best is to just do the latter. So we're actually going to need to call in the NPC, right? And then, or at least an NPC object, right? An NPC game object. And we're just going to go ahead and call a do work method here, okay? And so red squiggly lines, right? We haven't coded out all the stuff that needs to make this work. Okay, in order to call in the NPC class, that means that we need to feed in the NPC controller class into this execute method. So let's go ahead and do that. Okay, but you notice that it throws an error because in the parent class, the action class doesn't say that we need to call in, that it doesn't require the NPC class as an input. Okay, so let's go ahead and change action so that it requires the NPC controller class. Okay, and you'll see why this is necessary in a bit. So let's go ahead and make sure that it has everything that it needs, the namespaces. Okay, so now the parent action class, in the execute method, it requires the NPC controller. But notice that the scriptable object actually doesn't have, the scriptable object action class actually doesn't have the NPC controller class anywhere in it. Now, why is that? Why didn't I just create, a field here that says, public NPC controller.npc like that, and then we can just add it in here? Well, the thing about a scriptable object is that they are stateless objects, which means they are not aware in editor time, it is not aware of the game objects that exist in your scene. It's kind of like an asset. And it doesn't have any knowledge before if you haven't pressed the play button, it doesn't have any knowledge of what an NPC in the game scene is. That's why we can't just create a public field here and add things to it. Okay, so well, actually, we can actually even demonstrate that right now, right? So if let's leave it like this, right? Even like if it's like this, and then let's just comment this up for now to demonstrate why this would not work. Okay, and then this is a scriptable object. So let's go ahead and do a create asset menu. Okay. Now let's demonstrate why creating this public field here for NPC controller doesn't actually work, even though we do need the NPC class in this execute method. So if we go to our action class here, and let's go ahead and create a new folder here, call it scriptable objects, and actually create the work scriptable object, right? Work. Okay, and let's take a look here. You can see in the inspector here, it looks like we can just drag and drop things into here, right? But you can see here, we can't, right? I try to drag the NPC controller here, because the NPC controller is attached to this NPC class here, okay? So if we want to, ideally, we would want to just be able to drag and drop it here, but we can't do that. You can see here, we can't do it. Even though this requires an NPC controller class, there's nothing that it can grab to fill that in. That's because scriptable objects are, as I said, stateless. They behave like assets just in your folders. They don't know anything that's going on in the game scene. And so you can't just create public fields like this and try to reference game scene objects. So that means, but that doesn't mean that we can't do this, right? That doesn't mean that we can't feed the NPC controller class into our execute method. It just means that wherever this action is called, whenever it calls an execute method, it has to give an NPC controller class to it, like an NPC controller object to it. So in our work method, that we do this, right? This logic still calls an NPC controller, but that just means that in our NPC controller class, we need a method that says do work. So let's go ahead and go and create that method in our NPC class. Okay, I'm going to go ahead and create a section of code here that is our coroutines that will do all the logic for these actions. All right. So these methods that the action actually calls are going to be coroutines. And we're using coroutines because these actions, right, they take time to do. When you're working, like chopping down a tree, mining, or farming, right, you need that like kind of like countdown to say when you actually grab one full resource, right? That's how we're doing this. There's different ways on how you can do code the logic for work actions, such as chopping trees, farming resources, mining rocks. You can either, do it by implementing like a damageable class and attaching that onto the script, onto the game scene object. Like, for example, this tree here, right? And then the NPC can go ahead and hit that tree, and once the tree's health falls to a certain level, then it disintegrates and gives the NPC some resources. That's one way of doing resource farming logic. Another way is to just implement like a timer where when it reaches the game object tree here, it's going to stand there and play its animations for a certain amount of time, and every X amount of time it harvests one resource from that resource object. And we're going with the latter. We're going with that logic where it's just a countdown timer. Okay, that's why npc.doWork and npc.doAnyAction is going to have to be coroutines. So let's go ahead and code out that coroutine for work in our NPC controller. Okay, so we're going to have a public void doWork method here, and we're going to give it a time, right? How long does it take for it? And this time here is how long it takes for it to actually harvest one resource. And then we're going to go ahead and do a start coroutine, and we're going to call in a work coroutine and give it the time. All right. Now let's go ahead and code out this work coroutine. It's going to be an IEnumerator work coroutine int time, and then it's just going to do a countdown, right? Whenever this NPC starts working, it's going to start counting down before it gives it a resource. So we'll start a counter, and we'll put it in. We'll do a while loop while the counter is greater than 0. Then just keep counting down. We're going to wait 1 second. And then once 1 second is up, reduce the counter by 1. Okay. And then because we don't have all the other scripts to actually control these resource object storage and stats and hunger and all that, we're just going to do debug messages here so that we can display a message saying we're actually working. Okay, so this is more of like we're coding out the concrete actions, but we just want a proof of concept that everything works for now. Okay, so we're just going to do a debug message that says I just harvested one resource. Okay. And so that should be the coroutine that takes care of the logic when this NPC walks up to this tree and starts cutting things down. Okay. Now let's go back to our work action. Okay, so it's red squiggly line because we actually need to provide a time. And so let's just say this time here is going to be the amount of time that it takes to harvest one resource. And so let's just say that harvesting one resource takes, 3 seconds, right? So we'll give it 3 here. And so now our work action inherits from action. It requires it to, that means it requires, it's required to implement this execute method. This execute method calls in an NPC object, and then it'll use that NPC object to access this do work method here. And this do work method here is located in the NPC controller here. This kind of programming pattern is called dependency injection. Okay. For a long time, when I first implemented this code and did this, I didn't even know that it was called dependency injection, but as I continued working and reading and stuff, I realized that, I accidentally implemented dependency injection, right? And dependency injection, all a dependency injection means is that your class doesn't have a local reference to a required input here. But you can still require it. That just means that whatever is using this action, in this case work, will just have to inject that object into that method. And for us, it's this work method is injecting the NPC controller into the execute method, which then calls in the do work method that exists on the NPC class. Okay. Hope that makes sense. It is a kind of confusing concept when you first encounter it, but it's really powerful once you actually get to know how to use it. Okay. So that takes care of the work action. Okay. Let's go ahead and code out the other actions. What other actions did we have? We had the eat and sleep action. So let's go ahead and code out the sleep action. Sleep action is going to be very similar to the work action. It's pretty much the same exact kind of logic because, right? For the work on a resource, it just goes there, stands there, plays the animation, waits for the time that requires to harvest one resource. For the sleep method, it just goes home, stays there until its energy increases by 1, right? So it's very similar. It's basically the same logic, just two different types of work or different types of action. Not different. Yeah, it's the same logic, but two different actions. Okay. So the sleep class will be pretty much the same thing as the work action in terms of logic. So let's go ahead and just copy paste that code then, and then change the names. Instead of work, it will be sleep. And instead of work, it'll be sleep. Sleep. And make sure to call in the right namespaces. Okay. And now instead of do work, we're going to have a do sleep method, right? We're going to do a do sleep method, and we're just going to keep the time here the same. Let's say it takes 3 seconds for it to replenish 1 point of energy while it's sleeping, okay? And then we'll go into the NPC controller class and write out that the coroutines to do sleep, the sleep action. So we'll create a coroutine or a public method here that calls in the coroutine. We'll just copy paste that code here also. Change this to sleep coroutine. And then we'll actually write out the actual coroutine itself for sleeping. Okay. Call it sleep. And it's basically the same coroutine logic. It's going to wait for 1 second, but it's going to wait for a certain amount of time in order to recover 1 energy, right? And then we'll change this debug message that says, I slept and gained 1 energy. And this is the logic that actually takes care of updating all those changes when it's performed the sleep and the work action. So we'll just make a note here to say that we have to come back here and actually implement that logic, and that will be done in the next parts. Okay, logic to update energy, and then here in the work coroutine, logic to update inventory. Or I think there's a couple different things. So we'll just say update things involved with work, because when you work, right, it might depend. You can code out basically whatever logic you want to happen when it's working. So updating the inventory, updating the money that has updating its energy, whatever. But we'll come back to that right now. All we want to do right now is just try to get the messages to display right so that we have a proof of concept that things are working correctly. Okay. Work coroutine, sleep coroutine, same logic. So their code looks pretty much identical, just the names are different. Let's see, work, sleep. Okay. So now let's take care of the third concrete action, which is eat. Eat. Okay, so for the most part, all this will be the same, but there will be one little different thing. Let's go ahead and paste all that. Change the names. Eat, and eat. Okay. And then here's where eat is different from sleep and work, right? Sleep and work are actions that take time to do for this simple setup here, right? When it goes up to the tree, it takes time to gather one resource. When it goes to sleep, it takes time to gain one more energy point. But eating, for simplicity's sake, we're just going to say that when eating is going to happen instantaneously. So when the eat action is called, this NPC is just going to eat food from either from its inventory or from like a shared pool of food in the village inventory, right? There's, it's really up to you how you want to implement these the logic for these actions. If you're playing like a God Simulator game, or if you're creating like a God Simulator game where you don't care if, animations play when he's actually eating or if he has to walk to some place to grab food and eat and all that, then, a simple way you can do it is just when this eat action runs, just instantly reduce the NPC's hunger by some amount. And that's what we're going to do here. For simplicity's sake, because this is just a simple example villager behavior. Okay. So that means that we don't actually need a coroutine because nothing is happening over time, over multiple frames, right? So we can just go ahead and write all the logic we want here directly. We don't need a coroutine, but, we might have, let's say like a class, NPC stats, that's attached to the NPC, and he has a hunger, and we might go ahead and, reduce it by 1 or something like that, right? I'm not going to get into that yet because we actually have to like code out the stats and a bunch of other things that I'm going to do on the side, so that, but that's not the focus of this, tutorial series. Is we're not building up stats class, we're not building up all that, we're just trying to build utility AI on top of it. So in the next episodes, I'll include all the other different classes that are required to make this scene work. Those other non-AI related classes such as stats, money, resource, and all that. And then I'll put it in the project files so that you guys have access to it. For this tutorial series, we're just strictly focusing on the AI and trying to get things to work together. So for now, let's just say that the eat action creates a message that says, I ate food. Okay. So whenever this action runs, this eat action runs, it'll just debug a message that says, I ate food. All right. So that takes care of our 3 concrete actions for this simple villager behavior. The work action and the sleep action, both of which occur over time, which is why we need these coroutines. And the eat action, which happens instantaneously, so we can just go ahead and implement all the logic here. And let's go ahead and make a mental note here. Logic for updating everything involved with eating. Okay, and it's going to take place directly in the execute method here. Okay, so those are our 3 actions. Now let's go ahead and create those scriptable objects. Right, we already create the work action. Let's create. Let's see if they showed up in our inspector. Yep, they showed up in our create asset menu. A sleep action and an eat action. Now let's take a look at these scriptable objects here. You can see here, right? We have to give it a list of considerations for each of these actions. They require a list of considerations. So let's go ahead and create those lists of considerations. Here, I'm just filling out the names in this name field here. Okay, so let's go ahead and now think about the considerations that go into these actions, right? So for the eat action, what is a consideration that goes into the eat action? A consideration that goes into the eat action is its hunger, right? How hungry am I before I eat? If I'm very hungry, I'm going to go ahead and eat. If I'm not that hungry, I'm not going to eat. For sleep, a consideration for should I go sleep is, how much energy do I have, right? So that for sleep, the consideration will be energy. And for work, we can say, let's say that its motivation to work is the amount of money it has, right? Every time it farms one resource and drops it off, it's going to go ahead and make a certain amount of money, right? And that's the driving force behind, that's the consideration that this NPC will take into consideration. That's the consideration that this NPC will have in order to do this work action, okay? So money drives him to do the work action. Energy drives him or her to do the sleep action. And hunger drives the NPC to eat or not eat, okay? So let's go ahead and implement those three considerations, those three very simple considerations. Now, note that, there's you as the creator of this AI have the freedom to create whatever considerations and mix and match them whatever way you want, whatever way makes most sense to you for your villager. And that's kind of like the power of utility AI. It gives you the freedom to create whatever actions you want and then assign whatever considerations you want to those actions. And it's like playing around with puzzles to see what works best to give you the most realistic behaviors. Okay. So let's go ahead and create these consideration classes. And one more. We'll call it the money consideration. Okay. And just like the actions, we're not actually going to implement like the complicated logic that goes into it yet. We're going to just manually put hard code numbers in so that we can see that our AI brain is actually working. Okay. So let's look at the money consideration and look at its code, how it should be structured. Okay. Money consideration inherits from our consideration class. So let's go ahead and do that. And then let's make sure that we're using the right namespaces here. So money consideration inherits from the parent class of consideration. So let's go ahead and implement everything that it needs. And you can see here, it only needs the score consideration, right? Just like the action class, action parent class, right? It has all these other things in here, but because it's a parent class and it's a scriptable object, and the only method that we actually have to implement from it is score consideration. Everything else kind of stays the same for across all the considerations. Now this is where the customizability of considerations comes in. In the previous episode we talked about how why this score consideration is located internally within the consideration class, whereas in actions there is no score actions. It actually sits in the AI brain. Why is that? Why? Because in the consideration class, score consideration, the logic for scoring consideration can change for the different types of considerations, right? How you score how you score hunger, energy, money, criteria for do I have this object in my pocket? All that, the logic for scoring those considerations vary across all different ones. So for money consideration, for score consideration, when we score the consideration, it should return us like a score, right? Based on various things in the world. For money, For right now, we're just going to go ahead and return hard-coded values so that we can actually see the AI brain working. So in this first dry run bare bones test, we just want to see that the NPC wants to work. Okay, so we're going to make sure that he returns a really high value for work, specifically 0.9, right? Because as we said, scores for actions and considerations have to be between 0 and 1. And since we want the consideration of money to be highest so that this NPC will always want to work. So we're just going to go ahead and put a score of 0.9 or 1, so whatever you prefer. But I'm just going to make them so that it scores highly. Now let's go to the other two considerations. And it's going to be an exact, or not exact, but same logic. So we're just going to go ahead and copy paste things here and change names. Hunger consideration. And we will give it a score of 0.2. So hunger is not that important yet. And then I forgot to do the whole create asset menu so that we can see these considerations in our menus. And lastly, the energy consideration. Okay, and we'll say the energy consideration for sleeping is just 0.1, right? Something really small. So you can see here, right? Money has the highest consideration, hunger has the second highest, and energy has the lowest. So when this utility AI starts running, it should automatically see that, oh, money is the most important thing for me right now, which means I'm going to go ahead and work. Okay. These numbers here, right? These numbers that I entered here will actually be computed or calculated by some sort of logic that goes on in these consideration classes. But in this part, we can't do that yet because we don't have all the different parts of this test scene that is needed to work, right? For example, we don't have a stat yet for hunger. We don't have a stat yet for energy. We don't have a stat to keep track of how much money this NPC has. In the next part, I'll actually build those in, and then we can just jump on coding that logic from the get-go. Okay, but for this part, we just want a proof of concept that things are actually working. So let's go ahead and go back to our to Unity and create these things. So let's go ahead and create a folder for scriptable consideration objects and actually create them. So let's take a look. Utility AI, considerations, and energy. Okay. Hunger and money. Okay. Now let's take a look at them. All right. Let's go ahead and enter their names. Energy, hunger, and money. Okay. Now let's take a look at the action scripts and go ahead and attach those considerations onto there, right? So the eat action depends on the hunger consideration. The sleep action, let me blow this up so we can see it. Sleep action relies on the energy consideration, okay? And the work action relies on the money consideration. All right, so our work actions are all set up with their considerations. Now let's go back to the NPC and actually attach those actions onto it, okay? So let's get rid of all these excess actions. We know that we only need 3 actions, right? The first action is eat, the second action is sleep, and the last action is work. All right, so our NPC controller has its list of actions. Each action in here has their list of considerations already. Are we ready to press play? Not quite yet, all right? We're almost there. Bear with me here. An important thing to notice is, even though we have all these actions and considerations set up, let's go look at the NPC controller and the AI brain again. Notice that we don't actually have the logic yet anywhere to tell this NPC, hey, you need to decide an action right now, right? In AI brain, we just have all the logic for scoring actions and picking out the best actions, but nothing telling it to pick out a real action or to kickstart the process of deciding actions, right? Same thing with NPC controller. We don't have any of that yet, so we actually have to code that in. So in our AI brain, let's go ahead and add a little bit more to it. Okay, we're gonna create a tag here that says finished deciding, right? And we're gonna set this to true. All right, this tag here is gonna tell us, right? And let's go ahead and create this tag here. It's gonna be a bool. So call it public bool finished deciding. Give it a get set. Okay. So this bool here is going to keep track of whether we're done deciding an action. When we're done deciding an action, then the NPC controller will be given a cue to actually execute that the newly picked best action, right? That's why we set it to true here. So this bool here, you can see once we pick out the best action, go through all the logic, we set the best action here, we set the finished deciding action to true. And then the NPC controller will always be listening for the tag to see if it has been updated. Okay, so in the update method, we'll put in brain, AI brain. If AI brain finished deciding is true, then first set it to false again, and then execute the action. Best action dot execute. And then we remember, right? The execute method requires the NPC class. So we're going to go ahead and feed it this. Right? This NPC that's calling this best action injects itself into this execute method so that these actions can call the coroutines here. That's called dependency injection. All right. And these coroutines here, we coded out the logic here. Okay. So let me just double check that we have everything. And then one more thing, right? One more thing. When we first start as soon as we press play for the scene, there's no best action yet. So we actually have to decide a best action on the very first frame of the simulation. So in the update method of the AI brain class, we're going to go ahead and do that. We're going to say if best action is null, then go ahead and decide my best action and feed it in the best action actions available. We have to NPC, right? Right, NPC.actions available, because the list of actions is actually attached to the NPC controller. So decide best action and give it the list of actions available on this NPC. All right. So I think that should do it. Now we have a way to perpetually drive this NPC to just make decisions on its own. All right. So let's go ahead and press play and cross our fingers that I have not been lying to you guys about this coding structure. And we'll pay attention to the console, right, to see what happens in the console. As I said, there it is. I just harvested one resource, right? What do? We set up this NPC to always want to work. And now he's working. Every 3 seconds, did we say? Every 3 seconds, then he harvests the resource. So we should just keep seeing this message pop up over and over again. But we only see it once. So it looks like it does it once and then it stops doing it. Oh, Okay, here's another thing we forgot. Notice that if we go to the NPC controller, right? Once it finishes this coroutine here, the work coroutine or the sleep coroutine, it doesn't tell the NPC to decide again. So we actually need a way to tell the NPC that, hey, once you finish doing one action, decide what your next action is again. Okay, so let's go ahead and do that. So in our work coroutine and our sleep coroutine, had this logic to update things involved in work, and we also have decide our new best action after you finished this one. Okay, so we're gonna need a method that says on finished action. Okay, upon finishing this action, right, we should kickstart the new process of picking out the new best action. So let's go ahead and create a method here that says public on finished action. On finished action, just decide. Oops. Yeah, brain. Decide new best action and give it the actions available. And this is all sitting on the NPC controller, right? Okay, so now once you finish this work coroutine, go ahead and decide the new best action, basically. And then let's give it also to our two other actions here. And we'll just make a note also here so we know what's going on here. And then we'll also give it to eat, right? We'll put it right here. We'll say NPC dot on finished action. Boom, there you go. So once it's done eating, call this on finished action. Inside this unfinished action is decide your best action again. All right, so that should fix it. So let's go ahead and press play again. And he's remember the simple scene here, we told him that he wants to always work. He's a workaholic. So here he is, and boom, there you go. He just harvested his first resource, and there you go. Now it's a perpetuation of just this NPC doing its thing by itself, evaluating its list of actions to see which one's the best, and executing it. Once it's done executing, then it just restarts the process of deciding the new best action. All right. So that the action of work works. Now let's look at the other action. Right. Let's go back to our consider. How do we make it so that it does the other two actions? Well, we have to go to our considerations and change up the numbers, right? Let's say that the logic for computing the consideration of money now becomes returns a very small value, which means money is not the most important thing right now for him. Let's say he's hungry. He's very hungry, right? He's now going to the consideration of hunger is now going to return a high score, higher than the other two considerations. So when we press play now, we should see that he's constantly eating. So let's go ahead and clear the console and press play. And there you go. He's eating food now. Okay? He's eating food now because he's always constantly hungry, because we told him that the hunger consideration is the most important thing for him right now, which means the eat action is the best action for him. And then last but not least, let's go ahead and test out the energy consideration, right? Let's change this up to 0.9. And set the score for the other two considerations very low. Okay. And then let's press play to see if he's gonna sleep. We expect these to be debug messages to say I'm sleeping. All right, and there you go. I slept and gained 1 energy. And remember, sleeping takes time. So he sleeps for 3 seconds, gains 1 energy. He sleeps for 3 seconds, gains 1 energy. Okay. All right. So there it is. Our utility AI works. bare bones, very bare bones. We actually still have to go in and add in, stats for hunger, money, and all that good stuff that goes into RTS to get it to do some actually realistic logic, such as moving towards the resource to harvest the resource, moving to the storage unit over here to drop things off, and moving to the house itself to sleep. Okay, so in the next part, or in this part, we coded out just the concrete actions and concrete considerations, have them in place. We did a proof of concept to show that the actions and the considerations are being calculated right and evaluated correctly. So in the next episode, we're actually going to implement stats, or actually I will put these in. I'm planning to maybe just do them on the side and put them in so that we can just dive right into the AI part. But if you guys want to see how I set up like just prototyping like stats and stuff like that, let me know in the comments. If not, then I'm probably just going to go ahead and do them on the side and just attach them to the project, set everything up, and then we can just dive right into the code for the AI part, and so that we can start seeing this NPC move around. We still need the logic for moving to the resource, moving around to actually perform the actions. How to make this tree disappear once it hits 0 for its resource account. How to keep track of stuff, how much stuff is in the storage and all that. Okay, so those will be, that's the direction I'm going to head for this tutorial series. We're going to start, now that we have a working AI brain that operates on the principles of utility AI, we're going to start coding things out to see this guy, little guy, move around in the scene to do everything realistically, like an RTS simulation. Okay, so this video was a bit longer than the earlier ones, but hopefully that kind of proves that everything kind of works together. So with that, thank you very much for sticking around to watch this tutorial series, and I will see you in the next video.